Dear students, welcome and thank you for tuning in to this video. This is the third video of lecture 15, in which we are still talking about the measurement of the respiratory system. Here we are going to talk about the medical gases and safety systems. There are a variety of medical gases and cylinders and regulating equipment that are used by the inspiratory therapist. We have 6 regulating agencies and acts that are important to the respiratory therapist to know about, and also for biomedical engineers to know about. The first one is the National Fire Protection Agency. It's a voluntary agency that promotes prevention and detection of fire hazards. Also, you have the U.S. Department of Transportation, which regulates gas cylinder construction, testing, and maintenance. Also, we have something called the Compressed Gas Association, and this association actually develops safest methods for handling compressed gases. We have also 2 acts. We have the Federal Food, Drug, and Cosmetic Act that regulates shipment of medical gases in interstate commerce and provides standards through the Pharmacopoeia of the United States. Also, we have the Federal Occupation Safety and Health Act of the 1970, which is the OSHA, which is a very important act because it provides federal inspections of facilities used to store inflammable gases. Also, we have the local and state agencies that provide safeguards for their communities from the hazards of storing, transporting, and the use of compressed gases. It's very important for biomedical engineers as well as respiratory therapists to understand and know what are the guidelines and regulations that they need to follow for safety reasons. I would like to touch base on the cylinders. Gas cylinders are made from seamless tubing or from flat sheets of drawn steel shaped into a cylinder. Some common types that we see when we are using compressed gases, we have the ICC-3A cylinders, which are made of seamless high pressure tubing, and those cylinders could withstand 150 to 15,000 pounds per square inch gauge, and that is a pressure relative to the ambient pressure. We have also the ICC-3AA, which is a seamless high pressure cylinder that is above 3A rating. We have something called ICC-3B. It's a seamless high pressure, and it can hold gases with a pressure of 150 to 500 psi. We have the ICC-3E. It's a 2-inch maximum diameter with 24-inch maximum length, and it can withstand 1800 psi G, which is again pound per square inch gauge. The last type is ICC-8, and it's seamless low pressure. It can withstand 250 psi G for acetylene surfaces, which is actually the cylinders used for cooking, gas and light tasks. So the gas cylinders are dangerous, and if mishandled, they can result in fire and explosions. So it's important to understand what is written on these cylinders. So we have something called marking on the gas cylinders that is required to be there. So the first line, you will see what is the specification of which type of cylinder we are dealing with, and as well as the date and how much pressure, pounds per square inch gauge actually. And the second is the name or a number of the cylinder. The third line is the manufacturing marking, and the fourth line is the month and year of qualification test. So this is a general idea of what the markings on the gas cylinder means. So gas cylinders are usually used in hospitals and clinics and healthcare institutions through a piping system. And we have different ways and schematics of these piping systems. I'm not going to go through these schematics in details, but it's important for all biomedical engineers who work in hospital to understand what those schematics and how they're important, and how the cylinders are providing gas to the different parts of the hospital. So we have central oxygen cylinders supply oxygen to specific areas. through pressure regulating valves, and that maintains a pressure between 50 to 100 psi, which is again pound per square inch at the service outlet. Please keep in mind that the main supply must have shut-off valves and an alarm system. We should have separate station, manual or automatic shut-off valves are all should be required. Also, all personnel must be educated as to the placement and use of these valves on the cylinders. So what kind of therapeutic gases usually are used in ventilators and respirators? So we have oxygen, which is an essential gas for life, and it normally makes 21% of the room air. We have carbon dioxide. It's important to control the respiration and circulation, and it's usually 0.0 to 5% of the room air. We use also helium. It's a lightweight inert gas used in cases of respiratory obstruction. People also use nitrous oxide, which is an inorganic gas used as an anesthetic agent. We have helium-oxygen mixtures, and it's a low-density gas used for patients with asthma. Also, we have oxygen-carbon dioxide mixture, and this gas is used to stimulate deep breathing and to relieve cerebral vascular spasm. And as I mentioned before, these cerebral vascular spasms actually are the result of the contraction of the smooth muscles that are surrounding the vessels, the blood vessels of arteries and veins. Safety system in the hospital for compressed gas are essential. And we have two types of systems. So we have something called diameter index safety system, DISS, and that was developed by the Compressed Gas Association to provide actually interchangeable threaded connections. So each connection of the disc consists of a body, nipple, and a nut, similar to what you see to the right of your screen. However, we have something called pin index safety system. Is a two-pin approach that prevents incorrect interchange of medical gas cylinders with the flush type valves. So that's important. That's why people were making mistakes in hooking the connectors to the wrong gas connector. So it's important. The pin index safety system, or PISS, was developed to overcome this challenge. So usually we have 10 combinations are possible, of which 8 are in current use. So that's in a specific room or a place in the hospital. Once we have the two-pin approach, no two incompatible cylinders can be attached together. So this is a mechanism to prevent errors, similar to what you see in gas stations. So with diesel and gas, regular gas. So the hose are specific only for a specific dimension, in a specific dimension for a precise type of cars or trucks. So this concludes our lecture about the ventilators and respirators. I hope that, and the measurements of the respiratory devices and apparatuses. Thank you for watching. Until the next video. Bye.